Catalyst students. This is going to be our first attempt at trying to start flipping our classroom. I chose a basic solution because it's going to be very similar to the redox and acid solution, so it should be a little bit of a review. So this first part I'm going to go through quite quickly because it should be the same, and then you'll see at the very end how we adjust for the basic solution. So the first thing I need to do is assign my oxidation states. Remember, we're doing the one that has the highest electronegativity, which would be nitrogen at a -3. If overall this needs to be a -1, that would make my carbon a +2. Over here at oxygen -2, -8. Overall I have this -1 charge right here that you can see, and so this is going to be a +7. If I take a look between carbon, nitrogen, and oxygen, I have 3 elements. Oxygen's the most electronegative at -2. Then between the next two, it's going to be nitrogen, which is -3. And so if I need a -1 charge overall, my carbon's going to be +4. Then for oxygen, I have a -2, -4. And then for manganese, it's going to be a +4 charge. Now, similar to what we've been doing in class, we're going to bracket these and show what's changing. My carbon is changing from +2 to +4, which is a loss of electrons, so that makes this oxidation. Then I have my manganese changing from +7 to +4, which is gaining electrons, so that makes this reduction. So I'm going to start with my oxidation half reaction. And remember that we are just going to carry down the charges of the ones that actually change. And so the carbon is changing from a +2 to a +4. And now I need to balance out all of my elements. Carbon, carbon, nitrogen, nitrogen. That looks good. My oxygen, I'm going to balance with 1 water. And now I have 2 hydrogen ions on that side, so I'm going to put my 2 hydrogen ions on this side. Now I need to go ahead and I need to take a look and balance my electrons. So I have a +2 going to a +4. If I add 2 electrons, because you remember they are negative, that is going to balance out that half reaction. So now if I go to my reduction half, I'm going to go ahead and balance out my permanganate. And again, to my manganese dioxide, and I'm just going to carry down the charges that change. So manganese is +7, and here is +4. My elements are balanced. Now I need to balance my oxygens out with water. I have 4 on the left, 2 on the right. So I need 2 more waters on this side to have 4 oxygen. That gives me 4 hydrogen ions that are out of balance, so I'll add those to the left-hand side. And now I can go ahead and balance out my electrons. I have a difference of 3 here, so in order to balance that out to +4, I'm going to add my 3 electrons to this side of the equation. Now you're going to see that I need to have a common factor between the two. And so I'm going to multiply this top one by 3, I'm going to multiply this bottom one by 2. And you can see that I have done nothing new compared to the redox reactions that we've been doing in class. So I'm going to go ahead and, let me get that real small like that. I'm going to go ahead and write our overall reaction here so we can see how things are going to change. So I have 3 waters, 3 cyanides, then if I go ahead and do the other one where I've multiplied everything by 2, I have 6 electrons here, I have 8 hydrogen ions, I have 2 permanganate ions, I have 2 manganese dioxide, plus 4 waters. Okay, so my resulting equation here is now going to be, still let's make it even smaller again. Okay, so I'm going to my resulting equation here. I can see that I have 4 waters here, I have 3 waters here. My electrons are going to be able to cancel out. My hydrogen ions are also canceling out. So I have an excess of 2 hydrogen ions on this side that are aqueous. Then I have my cyanide ions that are also in aqueous. I have my also aqueous. and my excess electrons are gone. My water is on this side, but I have my two hydrogens to take care of. So that's everything on the left-hand side of the equation. Continue to add everything together. And that was in a solid state. And then I also have one water that is left over. Now, if I continue to move this down, you guys can see that this would be if it was a balanced equation in an acidic solution. I have a basic solution that make hydroxide ions. So because I have two hydrogen ions, I balance it out with two hydroxide ions. That's the basic piece of this. Well, just like in math class, if I add 2 to the left-hand side, I need to add 2 to the right-hand side. Now I'm able to simplify this out. And if you take a look at this right here, you can see that that is going to make 2 waters. So when I write my resulting reaction, if I grab a new page, sorry about that. If I write my resulting reaction, I am going to have water, 1 water, and remember that it's very important that we write all of our charges and all of our states, which I have been trying to get you guys to do in the final resulting equation. So this is going to be our redox equation in basic, and as you are doing this, it has to tell you if it's going to be acidic or basic reaction. So you're not going to be guessing about that. You will be able to identify this as a basic equation due to the OHs that have been added. So this is my final one. So what I want you guys to do is I would like you guys to balance this one right here and bring this to class on Monday, fully balanced out with a equation in basic solution. Have an awesome MEA. I hope you guys get some rest and come back excited to start flipping our classroom.